Hello and welcome. You guys have all been waiting for this awesome Monday because it is Maths Mondays on Learn Extra Live. How are you, Dina?
Good, thanks.
Good. We're doing maths today and we're doing trigonometry. Hey, Dina.
Yeah, grade 10s, we have done the session before, but we're looking at trigonometry again, the theory behind triangles and how the sides and the angles are related. So we're going to have another session on that. So join us in a little while.
Awesome. Revision is always good, as you guys know, and trigonometry is one of the best topics in maths. Tina, you can walk over to your board.
Thanks.
So you guys know, of course, that it is Monday, and we have some prizes. We have the Casio calculator, and we have the labeler. Make sure that on Facebook and on Twitter, you are the number one mindsetter today, so you can win prizes. Remember, every Monday, there's always prizes, and every Monday, I'm waiting to see that really special mindsetter. Of course, thank you to Liberty. Liberty is absolutely awesome. And our Facebook page, just for a reminder, is facebook.com/learnextra. And our Twitter handle is @learnextra. Guys, I'm looking forward to this lesson. So just make sure that you have joined us. And in case you're not here yet from school or you're just getting in, make sure that you hurry up and tune in so fast because we are ready for such an awesome trick show. Hey, grade 10s, I know you are. Dina, are you ready for us?
I'm ready. Thanks,
Awesome.
Katlehu. Right, time to get going on the trigonometry. And what we're going to do is three things. In the first section, we're going to just have a look at how to find the side and the angle of a triangle. In the second part, we're going to look at some trig equations. And in the last part, we're going to look at the Cartesian plane, which some of you may or may not have covered in class. So those who have, it will be good revision. For those who haven't, then you'll have it for the first time. So let's get going. The trig ratios, as we know, are defined by sine theta, cos theta, and tan theta. And without a triangle, we are unable to define the ratios. So over here on the side, I've got a diagram that depicts the side that is adjacent to the angle. And some of you may be saying, but this side is also adjacent to the angle. Well, that side is opposite the right angle, so it's always got a special name. So that side will be the hypotenuse. And that side is fixed. It doesn't change depending on where the angle is. So my hypotenuse is always the side that's opposite the 90 degrees. But now this white length here is opposite this angle. And we've now got that it will be referred to as the side opposite the angle, whereas the orange side will be referred to as the side adjacent to the angle. Now, if we were looking at angle A, for example, this white side would be the adjacent side to the white angle, whereas this side over here would be opposite to angle A. So let's look at the definitions. For sine, we need the side opposite, which is C, and we need it divided by the hypotenuse. So we've got the fraction C over B. Cos theta is the adjacent side over the hypotenuse, so that would be that fraction there. And tan theta is the opposite side, which is C over the adjacent, so C over A would define tan theta. So for those of you who have already done your own memorizing, there could be this code word, SOHCAHTOA, to help us remember how the sides are related to that angle. So that would be opposite of our hypotenuse, cos adjacent of our hypotenuse, tan opposite of our adjacent, so that this is referring only to the first letters of the ratio and then the fraction portion, C fraction portion, T fraction portion. Right, but this year there's also the reciprocal ratios that we need to look at. And the reciprocal ratios are cosec is equal to 1 over sine. So in any relationship, you would have it as the hypotenuse over the opposite. Then we would get sec, which is a reciprocal of cos, and there we would get the hypotenuse over adjacent. And then finally, the cot ratio is a reciprocal of tan, and that would be your adjacent over your opposite. So those are our reciprocal ratios. And if you take the product of sine and cosec, you'll obviously get 1, because since it's So we could write it over here that if I take cosec and I multiply it by sine, I will get 1. So it's just rearranging this equation to multiply across by sine theta is equal to 1. Right, in terms of calculations, what does cos 48 degrees give us? And for that, your calculator works quite well in just from left to right. So cos 48, you would just fill in your angle and you would ask it for the ratio. And it's 0,669, usually 3 decimal places or sometimes 2. In this case, if we left it to 2, then it would be 0,67, correct to 2 decimal places. Then 2 sine 35, we would have a coefficient of 2, so we're doubling whatever sine 35 is. So double what sine of 35 degrees is, and that gives us 1,15. 1,15. Tan squared 81 is quite an interesting one because tan squared 81 does not mean that you square the angle, it means that you square the ratio tan 81. So if we have to rewrite this, we would say it's the same thing as tan 81 all squared. Okay? And the same thing would apply for 3 sine squared 72. But let's have a look at what that gives us. So we would get the tan of 81, and then we'd like to square it, and we would get 39,8. Now I just want to try something. If we have the tan of 81 and we square it, what do we get? 39,8. So as you saw earlier, the square was only around that 81, and it also gave us 39,8. So the calculator doesn't mind if you leave out those introductory brackets. So it facilitates the calculation there. So that gives us 39,86. 39,86. Right, and then 3 sine squared 72, what would that give you? 3 times sine of 72, and then we want to square it. What does it give us? 2,71. 2,71. Okay, so the only problem with the calculator is that you're seeing the calculator do this. You're seeing 3 times sine, and then the calculator does a 72 and does a squared. And it looks like the angle's being squared. So it's quite problematic on the calculator, the way it's showing it up. But you've actually got to understand that the calculator's not squaring that angle, but it's actually squaring the ratio. So if that confuses you, then you could just do that and put the square out there. Then at least you know that the ratio is actually being squared. Okay. Right, so that's just briefly how the calculator calculates the various ratios. Let's now go on to some questions related to, in each of these triangles, we are going to find the length of the side or the magnitude of the angle that is marked with a letter. So before we begin, I'm just going to, up here, put our acronym for reminding ourselves how the ratios actually work. Okay, so in this triangle, first focal point is to focus on the angle and to say, if that is my position of the angle, then how is this A related and how is this 62 related? Well, the 62 is definitely the hypotenuse, and the A is definitely the side that's opposite that. So in our scheme of things, we would have the opposite side, something about the opposite side, and we've got something about the hypotenuse. So therefore, that's the ratio that we are using. So you can always write that acronym to decide what has been given and how you're going to utilize the ratio. So we would start with the sine of 37. The sine of 37 is equal to the opposite over the hypotenuse, which is 62. And now we need to solve for that equation. So we've got A is equal to 62 sine 37. Once we're at this stage, we can now use the calculator. 62 multiplied by sine 37, and that gives us 37,31. So A is 37,31, whatever units they are giving us, in which case it doesn't have a unit at this stage, but this length here is 37,31. Okay, then if we look at the next one, and again, if we write up our acronym, just to establish what has been given to us. So we are given an angle, and we want to find the side that's opposite, and we've been given 21, which is the side that's adjacent. So if we go to the information, we want to find the opposite, and we have the adjacent. So that's my ratio that connects or links the opposite and the adjacent. So there's my angle there. So we will start by saying that the tan of the angle given is equal to my opposite over my adjacent. Again, I want to solve for B, so I want to multiply this side by 21. Look where I'm putting it. It's 21 times the tan of 23, because this gives me the ratio, and then I need to multiply by 21. It's not tan of 23 times 21, so I'm not taking the angle and multiplying that by 21. So now I can go to the calculator and say 21 times the tan of 23 degrees, and that gives me 8,91. So B forgotten what it is. 8,91. 8,91, again, whatever units you've been given. Okay, next one. Right, we've got, let's see, this one hasn't been given a side, so let's make that C there. Okay, so let's again write down the acronym, so Katoa, and which of these ratios will relate. So we've got the hypotenuse, so it could be sine or cos, and we've got what's this side in relation to the 55 degrees. It's next to it, so therefore it's adjacent. So we have to find the adjacent side, we have the hypotenuse, so we have cos there. We can say therefore that the cos of the angle is equal to the fraction C over 19. So C will equal, solve for C means we need to multiply by 19, so it's 19 cos 55. (19 times cos of 55). Okay. Right, we can go into the calculator. 19 times the cos of 55, and we get 10,90. 10,90. Right, this one, let's write down our acronym, and let's go back there. So let's write SOHCAHTOA. And what have we got this time? We've got an angle, 49. And what is D in relation to 49? And what is 33 in relation to 49? 33 is the side that's opposite the angle. And no, 33 is the side opposite the right angle. So 33 is the hypotenuse. So we could have either sine or cos. But the moment we get a second side, it will eliminate one of those. This is the side adjacent to it. So therefore, this is your adjacent. And this is your hypotenuse. So we have the cos. So we will start with cos 49 will equal the adjacent over the hypotenuse. So therefore D is 33 times cos 49. In other words, using the calculator, 33 times cos 49 times the cos of 49 gives us, and notice the calculator doesn't need degrees because I've got my D. You must always look at the top of your screen, that tiny little letter at the top. There are 3 different angle measurements. There are degrees, there are radians, and there are gradients. At school level, we're only going to deal with degrees. But later on, for those going into technical subjects, they will use radians. And for others, engineers, etc., they will use gradients as well. So you need to check your calculator carefully that you're actually in degrees, because otherwise you're going to get completely different answers if you're using one of the other angle modes. So in this case, we get 21,65. 21,65, and that would be my D. Right, let's see what's happening over here. Okay, we've got an alpha. Okay, so for the first time we're looking at an angle. So let's see with our acronym what we have. Okay, so if we're looking for this angle, what is the side in relation to that angle? That side is the adjacent, and that side is the opposite. You agree? So therefore, we would be working with opposite and adjacent. So we actually need that ratio. So we always start with the angle. So tan alpha equals opposite is 4 and adjacent is 9. And now, how does the calculator know how to find the angle? Well, because it's very clever. The calculator has got a button for the ratio of tan, and as a second function, it's got tan to the minus 1. Cos has got cos to the minus 1, and sine has got sine to the minus 1. So these yellow buttons here are the buttons that find the angle for you. Now, you don't need to write down what the button is or what that function looks like. All you need to do is to take your calculator function, so tan to the minus 1, and you need to fill in that we have a fraction 4 divided by 9. And now the calculator will give you automatically what alpha is. So we don't fill in any minus ones. We just use the calculator and write down straight away what that angle is. And what's that angle? Let's see. Would you like to try and guess? 4/9 is just half of that 1. So let's see. What is it? 23,96 degrees. So that's 23, oopsie. 23,96 degrees. Okay. And over to you, Katlego.
Thank you, Dina. So guys, we're going to go for a really quick break just for you guys to sort your stuff out, write down your rules so that when you come back, you are actually on the ball. See you after the break.